Now, using the dot product, we can measure the work done as the dot product of the force and displacement, which is equal to Fd cos theta. However, the work done can be positive, negative, or zero depending on the values of the angle between the force and the displacement theta. The work done by a force is positive when the angle between force and displacement is acute. That is, the angle is less than 90 degrees. An example of this is when an apple falls freely towards the earth. The work done by the gravitational force on the apple is positive. In this case, the angle between the displacement of the apple and the gravitational force is 0. Similarly, when a spring is compressed, the work done by the compressing force is positive. In this case too, the angle between the direction of the applied force and displacement, which is the compression of the spring, is 0. The work done by a force is negative when the angle between force and displacement is obtuse. That is, greater than 90 degrees and less than or equal to 180 degrees. In the case of a rising balloon as shown, the work done by the force of gravity acting on the balloon is negative, since it is opposite to the displacement of the balloon. In the example of a boy lifting a stone, the work done by the gravitational force on the stone is negative, as the displacement is against the gravitational pull. The work done by a force is 0 when the force is perpendicular to the displacement. Consider a block moved over a horizontal surface. In this case, the displacement is along the horizontal, whereas the gravitational force, which is the weight of the block, acts vertically downwards. Here, work done by the gravitational force is 0, since it acts perpendicular to the displacement of the body. As another example, consider a stone tied to a string, whirled in a circular path. Here, a centripetal force acts on the stone to maintain its circular path. Centripetal force is always directed towards the center of the circular path, whereas the displacement of the stone for an infinitesimal time interval is along the tangent to the circle at the point under consideration. As the direction of the force is perpendicular to the displacement, the work done by a centripetal force is 0. The SI unit of work is Joule, which is denoted by the letter J. Named after the famous British scientist James Prescott Joule. Thus, 1 joule is defined as the work done on a body when a force of 1 Newton displaces the body in the direction of the force by 1 meter.